Welcome to Planet Geography. Today we are tackling tsunamis, and there'll be an exam question at the end that will model for you and show you how I can turn this process into full marks, okay? When we first think about tsunamis, we should probably understand there are 4 sections to it, okay? They can be broken down into the first section, which is about kind of the conditions you need. I hope you know tectonic events only happen on tectonic plate boundaries. In this instance, we'll have a continental plate, and we will have an oceanic plate. The oceanic plate is more dense, and the continental plate is less dense. What you really need to know is that they are moving in opposite directions, making this a destructive plate boundary, okay? Or convergent plate boundary, which is commonly used by exam specs. So they're moving towards each other. The more dense oceanic plate is going to be subducted, which means pushed down, and the continental plate, which is lighter, less dense, is going to be flicked upwards, okay? So, it's going to be flicked upwards. And what happens with that huge amount of energy that's being released is the water above it is going to be displaced. It's going to be pushed upwards. And then what goes up must come down, is going to come down. And that's really the end of stage 1. So, getting straight into step 2. What's going to happen here is that energy as it comes down is going to move out in all directions. And so, seismic energy is going to move out in all directions from really the epicenter where this earthquake has taken place on the ocean floor. As it travels, you need to know that it's the energy moving through the water, not the water moving at 500 miles per hour. It's a common misconception with tsunamis that the waves aren't moving at 500 miles an hour. It's actually the energy moving through the waves, that seismic energy. At this point, the effects on the ocean are quite insignificant, really. The waves are very, very small. In fact, you probably wouldn't even notice them. As a result, safest place to be in a tsunami is out at sea on your fishing boat. This dude here is absolutely buzzing, okay? Wouldn't even notice what's happened, okay? But these are called tsunamis, which is a Japanese word for harbor wave, okay, which leads us nicely into our third phase. We call this wave shoaling. So that seismic energy is forced into a smaller and smaller and smaller space. And the water that is displacing and it's moving is also forced into a smaller and smaller space. And so those waves that we just said were insignificant suddenly become very significant. As they get closer to our shoreline, they get larger and larger. Now, again, these waves probably on average max out about 30 meters high. So they're not the 200 meters you might see online. They're also not one wave. They can be a series of waves, okay? And so as wave shoaling takes place, we also need to know that there is friction with the seabed. And so the waves really only move at about 30 miles per hour, okay? So the seismic energy might be moving at 500 miles an hour through the water, the speed of a plane, but the wave itself is actually only moving at about 30 miles an hour. Which then leaves us onto our 4th stage, our final stage. And again, it's the idea of what goes up must come down. It's the idea of gravitational potential energy. And if you can make the connection, it's about swash and backwash almost from our units on coasts and our formation of waves. The wave moves inland, causing huge amounts of death and destruction. Okay, buildings destroyed, people end up losing their lives, okay? But eventually, that wave will lose energy as it's moving uphill above sea level. And then once it has lost that kinetic energy, will return to sea level, and it will drag many things with it. So this is why you often don't tend to find many of your dead in a tsunami, is that they are often dragged out to sea. They could be dragged out with all sorts of things, okay? This poor bloke in the fishing Fishing boat, his car potentially his house, potentially his family. Okay, so that is the process of tsunamis. I'll just quickly recap it. It comes from a convergent plate boundary. The continental plate is flicked up, displacing the water. Step 2, seismic energy is released in all directions, moving at about 500 miles an hour. Wave shoaling takes place as waves begin to emerge as it's forced into a smaller space, but also slow down due to friction with the seabed before stage 4, which is when it goes above sea level, causing huge amounts of coastal flooding, destroying hotels and fishing villages, and then before returning to our sea level to complete the process. All right, guys, we're now going to jump into an exam question. So just hang around if you want to see that. If you don't, like and subscribe for future videos. I'll be making more in the next couple of weeks or so. Look at a question from the Geography B paper 1 section. So let's get straight into it. Here's our question. So this guy here, bug, box the command word, underline the keywords, glance the marks. Explain is our command word, so we're going to box it, means the word because is going to be kind of a key here. We're going to underline the keywords, earthquakes, cause, tsunamis. All right, so it's a pretty simple question. We then glance at the marks and we see it's 2 marks. That tells us we're going to get a mark for our point and a mark for our development of that point. Okay, so it's going to be 2 marks, 1 sentences. All right, so pause the video, maybe have a read of this. This is the mark scheme, seeing what you could get. I'll quickly run through it afterwards. We can see here the first one is the simplest. Okay, the movement of tectonic plates. That's going to get you a mark, right? As we know, all tectonic hazards are caused by the movement of tectonic plates. Causes water to be displaced. That second word there, displaced, that's where the second mark is awarded. The next 2 are much more difficult, and they get the same amount of marks. So generally, I'd say keep it simple, get the marks, and move on and save that time. As a denser oceanic crust sinks beneath the continental crust, again, that's quite complex, the oceanic crust may flip, causing water above to move. So that second mark is for flip. Continental and oceanic crust is the first mark. And then this last one, subduction zone, displacement of water. Okay, so I'm going to show you one that I wrote that I think would get 4 marks. As an examiner, I feel quite comfortable in saying that. One blank is. Now, if you read that question, always try and take words out of the question if you can. One cause is. And then that is your point, and then developed with because. So let's see how I did it. One cause is the movement of tectonic plates. Dead easy. There isn't anybody that can't do that. Because this can lead to the large scale displacement of water. So as an examiner, which I have been, I'm skim reading this and I'm seeing movement, tectonic plates, there's your mark. Because displacement of water, second mark. Okay, and that's really what examiners are looking for. They're looking for a little bit of structure with your connectives, and they're looking for the keywords that activate them toward the marks. Okay, so always remember, what kind of language am I using? Is it enough to pick up those marks? All right, guys, hope you found that useful, and stay tuned for the next video.